Hello students, today we will discuss about multiplate capacitor. A multiplate capacitor is essentially combination of two or more capacitors. Here number of plates should be greater than 2, like we have in this example 4 parallel plates. Now the plates should be connected alternately to the left and right ends. As you can see here, the top plate is connected to the left, the next plate is connected to the right, and so on. Therefore here we have total 4 plates. Now if you count the number of gaps, then you will see here we have 3 gaps, and the gaps are of equal width. Here the first gap, second gap, and the third gap. These 3 gaps can be considered as 3 identical capacitors connected in parallel. If you see, the top plate is connected to the left part and the next plate is connected to the right part. Let's assume that the left end is A and the right end is B. So we can say these 3 capacitors, as we name it 1, 2 and 3, are connected in parallel between the points A and B. If you look carefully, the top plate is connected to end A and the next plate is connected to end B, and for gap 2 the situation is same, and so as for gap 3. Therefore these 3 capacitors are connected in parallel. Therefore the answer will be C equivalent equals to C plus C plus C equals to 3C, and we know C can be written as Ka epsilon naught by D. So our answer is 3 Ka epsilon naught by D. Now what will happen if the plates are not alternately connected? Like you can see in this example, we also have 4 plates, but the problem is the plates are not alternately connected. As you can see, the top plate and the bottom plate is connected to the left and the middle 2 plates are connected to the right. This is a very important question. Understand this very carefully. We know a capacitor will be valid, a gap will be called a capacitor if the 2 plates are connected to the left and right ends, not to the same end. Using this formula, the top gap is a capacitor, but the next gap, the middle gap, is not a capacitor because the 2 plates are connected to the same right ends. So I will put a cross there to indicate this is not a valid one. And if I look at the third or the lowermost gap, that gap will also be a capacitor because the 2 plates are connected to left and right ends. Therefore it is clear that though the number of plates is 4, number of gaps is 3, but all the 3 gaps are not valid capacitors. Only 2 are capacitors and they are connected in parallel as I mentioned earlier. So the answer will be C plus C, that is 2C. So 2Ka epsilon naught by D. Now it's time to check whether you understand this concept clearly. Now we have many plates, you can count it, and the plates are connected to the left and right ends like this. Observe very carefully. Look at the topmost gap. It will be a capacitor? No, because the two plates are connected to the left end. So I will put a cross sign there. The next gap is a capacitor because the two plates are connected to left and right. The next one is also legitimate. The next one is cross and the last one is again cross. Therefore, we have total 3 capacitors which are connected in parallel. So the answer will be 3C, that is 3Ka epsilon naught by D. And as I mentioned, you can always write C equals to Ka epsilon naught by D if K is the medium, K is the dielectric constant of the medium between the two plates, A is area of each plate, and D is distance between any two consecutive plates. I hope you understand this concept clearly. Now, in this problem, we have total number of tin plates 200, so n equals to 200. As I mentioned earlier, the number of gaps will be 1 less than 200, that is 199. We don't have to check it because in the problem it is given that the plates are alternately connected. Now distance between the two plates is given as 0.5 millimeter, which is 0.5 10 to the power minus 3 meter. The medium between the two plates is filled with a dielectric of dielectric constant 6, and C equivalent of all the capacitors is 0.4 microfarad. Since the tin plates are circular, we can say their area will be pi r square, where r is the radius of each tin plate, which is our answer. Here all the n-1 capacitors are connected in parallel, so our C equivalent will be n-1 Ka epsilon naught by D. By putting all the values in this equation, we can find R easily. And the value of the radius of each tin plate will be 7.77 10 to the power minus 2 meter, that is 7.77 centimeter. Let's go to the next problem. Let's come to our problem number 2. Here we have total 7 plates. The important thing is these plates are not alternately connected. So as I mentioned earlier, now we have to count the legitimate number of gaps which we can call as a capacitor. You can see from the picture the lower gap is not a capacitor because its two plates are connected to the left end, but the other gaps are capacitors. But the topmost gap is a different type of capacitor. It has a thickness 2D, not D as the other three ones. So its capacitance will be different from the other three. Let's capacitance of the other three each be C. So I can write C as Ka epsilon naught by D, as distance between two consecutive plates is D. Therefore, the capacitance of the top gap will be C dash equals to Ka epsilon naught by 2D. Therefore, these four capacitors are connected in parallel. The answer will be C dashed plus C plus C plus C. Putting the values, we will get 7 Ka epsilon naught by 2D. This is our answer. Understand this problem very carefully because it will be helpful in the next problems. Thank you. Now coming to problem number 3. This is a very interesting problem. First, draw the diagram again. Here you can see we have total 5 plates. The top and the fourth plate are joined together. The lower plate is called V and the third plate is A. We have to find equivalent capacitance between A and B. Here we assume the gap between the plates, each plate is D, area of each plate is A. Now see, the top gap, if I name this end as X, then the top gap is a capacitor between X and A of thickness 2D, and the next one is a capacitor of thickness D which is connected between A and X, and the lower gap is a capacitor of thickness D which is connected between X and B. Let us draw the first one, that is connected between A and X, and it has a thickness of 2D. Now this capacitor is connected between A and X again, so I will draw it parallelly, and the last one is connected between X and B. So this is the capacitor. Now you have to write their values. For the top one, the thickness is 2D, so it will be Ka epsilon naught by 2D, and the next one is Ka epsilon naught by D, and this one is also Ka epsilon naught by D. Therefore, the two capacitors between A and X are connected in parallel. Therefore, the equivalence would be sum of these two, and then it will be in series with Ka epsilon naught by D. So the answer will be 3Ka epsilon naught by 2D into Ka epsilon naught by D divided by sum of them. We know in series equivalent capacitance becomes C1 C2 divided by C1 plus C2, and the answer will be 3 by 5 Ka epsilon naught by D. Thank you, students. This is our last problem. You can see the top cap is a capacitor of thickness D which is connected between A and X. The second gap is also a capacitor which is connected between A and B. This one is connected between A and X. So I draw it. It will be A epsilon naught by D. The next gap is connected between A and B. Let's draw it. Now look at the next two gaps. This plate is B and this plate is unknown, and the next plate is X. So I can say a capacitor of thickness 3D is connected between B and X. Its value will be A epsilon naught by D. It is also A epsilon naught by D, but this is A epsilon naught by 3D. There is one more capacitor which is left, and that is the bottommost gap. It is connected between X and B of thickness D, so its value will be A epsilon naught by D. Now it's a very simple problem. These two capacitors are connected in parallel, which will give as 4 by 3 epsilon naught by D. This is connected in series with A epsilon naught by D. So the answer will be, the series combination of this thing will be 4 by 7 A epsilon naught by D, and finally it is connected in parallel to A epsilon naught by D. Therefore the answer is sum of these two things, which is 11 by 7 A epsilon naught by D. Now in the problem, A epsilon naught by D is given as 7 microfarad, so answer is 11 microfarad. It is given in the problem that A epsilon naught by D is 7 microfarad. So that's the end. Please like and subscribe my channel. Thank you.